Hello, welcome. Sorry we're not outdoors, but today we're going to be looking at a concept, the concept of machine learning. And I'm going to be completely honest with you, I have a little buzz right now and I'm experiencing one of the most shittiest points in my life. But we're going to be using a programming language called Python. We're going to be using some frameworks such as TensorFlow and scikit-learn. So let's just jump into this. I'm in a directory called Python, okay, installed in my programs directory on local app data. This is a common directory where programs run in the Windows operating system. So what we'll do is we'll move into the Python 35, which tells us that we have the version 3.5, and this version, and this is the only version that I've been able to find that's compatible with TensorFlow and scikit-learn. Tried to use Anaconda with different versions, but there's just a mishmash of, we don't want to go there. That's another discussion. Let's not worry about that. So let's look at scripts. This is another directory in the Python installation, and we're gonna call a program called pip with the method of install and scikit-learn. Okay, this is one of the packages that we'll need. As we can see, it's already installed, and we're going to look at another created by Google called TensorFlow, and we'll see that this is installed as well, just so you can see that what I'm working with on the Python programming language. Okay, so here we've got defined a data set with two features. Okay. The two features are ax, weight, and income, and they are giving labels. Okay, and we can make a determination based on features. We can determine what type of label do we give to this data set, to the parameters provided. In this case, we're giving ax, weight, and income to determine something. Do we have a poor camper or a rich camper? Does that make sense? It should. It's very clear. So what we're going to say is from sklearn import tree. And we're going to use tree to make a determination about features and labels. Okay. So let's define our features. Now we have to define our features in integer-based values. Okay, so we know that our ax weight can be defined as a 2. So we'll define a 2, or type 2, and our incomes are going to be defined on integer-based values. 0 for low, 1 for high. Same with our labels. Our labels would be defined the same way. 0 for poor, 1 for rich. So we've got a low income is 0. Okay, our 4-pound axe. Well, we know that if you have a 4-pound axe, you have a low income. If you have a 7-pound axe, however, you have a higher income. And for our 9-pound axe, we know that you have a higher income. And we'll have to define our labels. Okay, so our labels for each column are 0, 0, 1, 1. Now in much larger data sets, obviously there's going to be different processes for defining features and labels, but this is a basic example, and I just hope that this intrigues you in some way or keeps you interested in my channel, because that's why I'm here, is to make a connection with you. Okay, so now all we have to do is instantiate a classifier. Okay, and a classifier is essentially something that will be trained in order to make a prediction. So we'll define a variable called c, and we'll use our tree to instantiate a method or object called, and people are going to come in to trash me here. I'm telling you in the future. Excuse me. But I'm trying to keep it as simple as possible. Decision. And this is the hardest part for me. Decision. Because I can't spell worth a damn. Decision tree classifier. And as I said, the classifier is trained, okay? So we're training this tree and decision tree classifier instantiation. Essentially is what we need to do. So we can say C is our classifier. C, the decision tree, is ultimately what this is, dot fit. And this is a method that will take our features and our labels, okay? And it will determine our prediction. Now I'm going to use a method called an if statement. It's used in many languages. It basically determines true or false based on its input. Okay, and what do we want to determine? A prediction. So we're going to say C dot predict. What do we want to predict? Well, we want to predict features given, and that we know that the features in our data set appear, which, let me tell you, this is just commented out code. This code is not executed or interpreted or compiled, okay? It's there, the interpreter doesn't see it. We want to say, hey, a 2-pound axe with a low income, remember we have to go off of that integer-based index, okay? If it equals 0, then we know, oh man, I always do this with this language. I work in many other languages as well. Print poor camper. Okay, otherwise, else, print rich camper. And I'm using the caps here, let's say poor as well. And I'm using the caps to see that it really has nothing to do with this. This is just the example. I realize that I have a lot of Buschcraft outdoor type of people that might not be familiar, but I just want to make it clear that it has nothing to do with what's defined up top. It's using the integer-based indexes, basically. It's the easiest way to describe it in normal terms, to determine what type of label we have, okay, in this machine learning concept. So we'll say, save by hitting Control S, and what we need to do now is go back into our Python 3.5 directory and call the Python executable, which is basically python.exe. We want to run our demo.py, which is a Python script. And we have an issue. I forgot to use the correct syntax. It's impossible not to make mistakes. Come on. And it's doing its thing. It's running the algos, and it determined that we have a poor camper. Okay? By the features defined, the 2-pound axe with low income. And we'll see that we have another poor camper by passing a 4-pound axe with low income. It's doing its thing, poor camper. Now if we pass the 7-pound axe with a higher income, it will be able to tell us that we have a rich camper. So it'll spit out rich camper, and a 9-pound axe with a higher income. We can think of our axe weight as our axe being gold. Okay, rich camper. There we have it. So there's the basics or intro to machine learning. I hope you enjoyed the video. I hope to be outdoors next time. Thanks for watching.